Okay, this whole chapter will be dealing with quadratic equations. So quadratic equations mean that my highest exponent is going to be a 2. So I'm going to be dealing with polynomials that have a degree of 2, in other words. So the first thing is just recognizing what it looks like. So like 3x squared is an example of a quadratic function. X squared plus 9, quadratic function. X squared minus x minus 2, quadratic function. So degree of all of those are 2. So notice that this is called standard form, just like we practiced with polynomials. So you will always have the highest degree first and then them getting decreasing with the exponents after that. So we first talk about a parent function, and you'll notice that from yesterday's activity that we were always comparing to that parent function. And so you were graphing them on Desmos and creating your own parabolas based off what Desmos graphed for you. We're actually going to take the time to find how to graph those today. So you were graphing parabolas, so that just noting the U shape there. And then when you have a parabola, you will always have an axis of symmetry. So for example, here on this parabola, this is an axis of symmetry, meaning that if I folded across that like a piece of paper, this side would fit exactly on top of this side. So symmetry meaning that they are exactly the same on both sides once I were to fold this. Okay? So the next piece is knowing a vertex and a minimum and maximum. So the vertex is the highest or lowest point within your parabola. So my vertex in this problem right here would be at 0, 0 because that's my lowest point. If my parabola will open up, that vertex is called a minimum. If my parabola opens down, that means that my vertex would be a maximum point. So the minimum and maximum is based off your vertex, and the vertex is that point that would always be on the axis of symmetry that you could fold across. So the first problem is we're just going to practice finding the coordinates of the vertex and finding if it's a minimum or maximum. So here's my first question. I went ahead and drew in my vertex right here so I could see that halfway point in between my axis of symmetry. So the coordinates of this point would be 0 for my x, since I'm not moving left to right, and then I moved up 3, so that means my vertex would be at 0, 3. Then I would see if it's a minimum or maximum. That's the highest point in this parabola, so it has to be a maximum. Next question. Here is my vertex down here at the bottom, so that would be my folding point. Coordinates of that point starting at the origin would mean I would move right 1 and down 1, so that means my coordinates would be positive 1, negative 1. Since it's the lowest point, that means it would end up being a minimum. Okay, so just looking to see which one is which. So I need you to pause the video now and try the got it question on the next page. So on the got it question, you should be finding the vertex, which is at -2, -3, because you went left 2, down 3, and then it is a lowest point, so it would make it a minimum. Okay, our next part is where we're going to practice finding domain and range. And this can be a little bit tricky, but we have to graph them in order for us to find that domain and range. So this wants me to graph y equals 1/3 x squared. It says make a table of values, what's domain and range. So you want to graph it first, and then we'll talk about domain and range. Now, when I get ready to set up my table of values, I will always use -1, 0, and 1. So on any given day, when this number in front is a whole number, I will always use -1, 0, and 1. However, on this first problem that they're giving us, it's not a whole number. So I would strongly encourage you, instead of using -1, 0, 1, we're going to use multiples of 3 instead, because my denominator is a 3. So whatever number's in the bottom, that's what you're going to use multiples of. So instead of using -1, 0, and 1, I'm going to use -3, 0, and 3. And the reason being is because when you start solving these out to find your y coordinates, you want nice whole numbers to graph. If you use -1 and 0, 1, you're just going to end up with decimals and fractions, which is perfectly fine. However, graphing those can get kind of messy. So I would encourage you again that if you get a fraction in front, to use multiples of that number rather than using the standard -101. Okay, so just notice that the bottom number is 3, so that's why I've changed it from -1 to -3. 0 stays the same, and 1 has changed to 3. Okay, so now talking through making a table. So this is from 1A stuff. You have made a table of values before and graphed. So if I was going to find the y coordinate, I have to plug -3 into the x spot and solve it out. So for example, this would say 1/3 x squared. Wherever I have an x, I'm going to put in -3. So now it's saying 1/3 -3 squared. Notice I put parentheses around there. You should be able just to type this into your calculator as one big string. So for example, if I were to type this into my calculator, I would have 1/3, and then I would need to put in parentheses -3 squared. So I would encourage you to go ahead and do it like that. Just make sure that you put a parentheses around that -3. So that answer just ends up being 3. So then I do the next set. I put 0 where I see x, so I have 1/3 times 0 squared. So I can type that into my calculator as well. So I do 1, fraction button 3, parenthesis 0, parenthesis squared. So my answer is 0. I do the next one. I do 1, fraction button 3, positive 3 in parentheses squared, and I also get 3. Now this should make sense. These two numbers should always end up being the same, because remember we talked about having an axis of symmetry. So if I have an axis of symmetry, which we're going to draw in, then these should always be the same distance and they should always have the same y coordinate. So from here to here will always be the same on both sides. So whenever you're doing this, those points around your vertex should be the same y coordinates. Okay, so now I'm going to come over and end up graphing. So this first point was -3, 3. So I go left 3, up 3. The next point was 0, 0, so it's right at the origin. And the last point was at +3, so I go right 3 and up 3. Then you're going to do your best effort in just drawing in a nice curved U all the way around there, and then put in your axis of symmetry at the end. So it's a little bit drawn out as far as the process because you have to make that table of values. However, it is important that you make sure you put parentheses around every time you're putting in that x value, okay? Alright, so there's my graph for that first step. Now it's asking what your domain and range are. Okay, going back to 1A stuff. Domain was all of your x values. Range was all of your y values. So as I look at this graph, I'm looking along my x-axis. My graph is touching the left side, and as I go across, it's still coming across to the right. So every time, your domain is going to be this answer, which means this is any number. So all real numbers means x could be any number I want it to. Okay? So keep in mind that this will always be the same, so it should be a gimme when you're doing your assignment or your quiz. Range though. Range are your y values. So the range will always be greater than or less than or equal to whatever your y-intercept ends up being. So here's my y-intercept. And so for this particular point on this one, my y-intercept is at 0. Notice that all of my y values stay above that y-axis. So all of my graph is 0 or bigger. So notice that I started at 0 and I put in the symbol to show that I am greater than 0 because all my y's were getting bigger than that. Okay, so my range will always be y, and then using your y-intercept number to determine is your graph getting bigger or smaller than that y-intercept. Okay, that's a lot to handle. See if you can try the got it question. Okay, in the got it question, here's what your table should look like. So this one has a nice whole number, so you should be able just to use -1, 0, and 1. You don't need to use multiples of 3. Okay? So with that being said, here's how you should be plugging it into your calculator. You should be doing -3. The -1 has to be in parentheses squared, so you should be getting -3. Then you should be getting 0 for the second one, and then -3 for, again, the other one. So when I plot those points, here's what my graph looks like. You should be at the origin, and then it should be opening downwards from that origin point. Domain and range, remember we said domain is all real numbers, so that's going to be my same answer every time. Your range, my y-intercept is at 0, and then notice where my y's are going. They're going down, which means that they're going to be getting smaller. So I would write it using y is less than or equal to 0. Okay, the last questions are based off what we've been doing with the Desmos activity. So whenever you are looking at equations or quadratic equations, it's going to want you to analyze, are my graphs getting wider, narrower, are we shifting up and down, left and right, are we opening up or downwards? So for this particular graph, it's asking from widest to narrowest, how do I know which is which? Well, they're giving you each graph, so you should be able to determine that. So see if you can go ahead and list them in order from the widest one to the narrowest one. So then I have this piece right here. My widest one is the 1/4 x squared. The next widest would be x squared, and then the last one would be negative 4x squared. The last question is pertaining to the same thing, where we're going to be talking about what do these numbers do to my graph. So this first number will determine if I open up or down, and also determine how wide I am. This last number will tell me if I'm shifting up or down. So if I'm comparing 2x squared plus 3 to just 2x squared, notice that these two pieces are the same, and that I end up adding 3. So this plusing 3 tells me I'm going to be shifting. If it's positive, I shift up. If it's negative, I shift down. So my answer has to be that it's shifting up. Okay, go ahead and start your worksheet for graphing.